Hey everyone. Oh, I got a weird little sign there. Let's get rid of that. Welcome back. Today we're in Unit 1, Lesson 9, 1-9. We're going to be making rate tables and equivalent ratios. All right, so let's take a quick look at some information that we thought about yesterday and see what we got here. I'm going to get rid of my face so you can see this in just a second. Maybe I can make myself teeny tiny. Oh, I can. Look at that. Okay, so ratio tables. Remember, I was making treat bags for teachers who helped me out. A ratio table, remember, it's a combination of two rate tables squished together. So we took the Twix and the Reese's tables. The linking unit was the teacher. We had one teacher, we needed 4 Twix. We had one teacher, we needed 3 Reese's. But when we had 2 teachers, we needed 8 Twix. When we had 2 teachers, we needed 6 Reese's. Now, I've got a surprise for you. William Grayson was helping me with my presentation today, and he's got much more skills, mad skills on Google Slides than I do. So get ready. Let's see if I can get it going, actually. Get ready. Here it is. This is what he designed for me. So there they come. That is awesome. Okay, let's see if I can go back actually and get that to happen again. All right, here we go. All right, so the 2 rate tables are coming together. They're being squished. They're squished out. The teacher, the linking unit is squished out, which is how many teachers there are. And here they come. There they are, Twix and Reese's. Squished out, and there's the ratio table with Twix and Reese's. So the invisible, what's gotten squished out and is invisible now, is the teacher. That's the linking unit. I think that's the same in both. We use that word linking unit to mean the thing that we squished out from 2 unit rates. So let's talk about equivalent ratios today. Equivalent ratios, they're ratios whose number relationships stay the same, but the actual numbers are larger or smaller. And that's the same thing as equivalent fractions, if you remember. Equivalent fractions have sort of their value is the same, but the actual numbers are different. So take a look at this. So Twix, there's 4. Oh, I'm going to try to get my little mouse going there. Twix, for 1 teacher bag, Twix is 4, Reese's is 3. There it is. There's that 1 teacher bag. But if we need 2 teacher bags, there's 1 and there's 1. The actual numbers are 8 and 6. That's an equivalent ratio to 4 to 3. So we can call it 4 to 3, and 8 to 6 is equivalent. Let's see if I can get rid of that. Oh, no, I can't. Oh, yeah, I can. Just got rid of it so I can't see it. Oh, this is tricky. I wish that would go away so we could see it better. All right. Well, it's thinking now. Oh, technology. All right. So what about 12 to 9? There's 1, 2, 3 candy treat bags. So the ratio is still the same. Notice how the amount of Twix to Reese's hasn't changed, but the total number of Twix, oops, my lights went off now. The total number of Twix to Reese's has changed. It's 12 to 9. Those are equivalent ratios. The actual numbers are larger or smaller, but the ratio of one kind to something else, that stays the same. So let's talk more about equivalent ratios. Let's take a look here. They're like more or less groups of the same. So you can see I circled a group up here of black. There's the one group for teachers. Then look at the group I circled for whoops, I'm going to go back. Look at the group I circled for in yellow. That's 2 groups. So there's the numbers 8 and 6. Now look at the ones I circled in blue. There's 3 groups. That's 12 and 9. So the actual number of candy is different, but the ratio, notice that the ratio of 4 Twix and 3 Reese's is the same even in this big circle. It hasn't changed the ratio of candy, in that there's more Twix compared to there is Reese's, and how much more is actually still in a ratio of 4 to 3. You can see that because you could get rid of that one line, you could get rid of the second one, and you can still see that first one. That leads us to an idea of the basic ratio. The basic ratio is the smallest numbers that you can have and still have the same ratio. For instance, we could say, okay, well, the smallest numbers I could have of each one is, if I want to have any, is 1 to 1. But that's a different ratio. That's equal, the same amount. That's like I have the same amount of Twix and the same amount of Reese's. And that's not the case here. They're not equal. There are more Twix compared to Reese's. So the smallest numbers that I can have and still maintain that same ratio is 4 to 3. So my basic ratio here is shown in one of the lines. Then all of these other ones, if we include all of these other, I could keep making even bigger circles and bigger circles to encompass that whole thing. Or I could look at it in a table like this. Those are all equivalent ratios. The basic ratio is the smallest number. And if you want to think about it mathematically and not logically, it's because both of those numbers are not divisible by anything that's not 1. Let's take a look at this 12 to 9. Both of those numbers are divisible by 3. 8 to 6. Both of those numbers are divisible by 2. 20 to 15. Both of those numbers are divisible by 5. 4 to 3. They're only divisible by 1. That's how you know you've got the basic ratio. Now, this is going to be fun because let's take a look at this McDonald's style. All right. Open your book. I'm on page 29, and you should be as well. On page 29, we're making ratio tables, the same things we've just been thinking about, making equivalent ratios and thinking about what unit is linking. What are the two rate tables and what gets squished out? That's the linking unit. So number 1 says Noreen makes 2 drawings on each page. There's a big clue. It says each page of her sketchbook. Tim makes 5 drawings on each page of his sketchbook. If Noreen is making 2 per page, Tim is making 2 per page, what's the linking unit? There it is. There are the 2 rate tables. Tim and Noreen, page 1, page 2, page 3, page 4, the number of sketches. When we shrink those 2 rate tables together, we get the ratio table. What is it that is squished out? What's the same? The thing that's the same is what's squished out. It's the page. So the page is squished out. The page is squished out. And here, and it's a little bit apart, that's where William Grayson's help with me with the Google Slides went. These 2 columns, the sketches, are what's squished together to make that new ratio table. Remember, how do you know a thing was a ratio table? Each side has to keep counting by the same thing. Noreen is +2, +2, +2, +2, +2 because she adds 2 new drawings every time. Tim is +5, +5, +5, +5, +5 because he adds 5 new drawings each time. Why does he draw so much more? I don't know. Maybe hers are more detailed and his are more sketches. Or maybe he spends more time. Maybe he has more time to do some drawing. We don't know. But either way, each time he adds 5 and each time she adds 2. What's the linking unit? The pages. The linking unit is the thing that was squished out if we made them into rate tables instead of ratio tables. You can reach me by email or chat, or you can see me in my office hours. Good luck.